Okay, welcome back. And this demonstration is about a triple point apparatus. And as with most of the other stuff I'm doing here, it's not all completely original, as in nobody's ever done it before, but maybe I've got a different twist on it or a different explanation or a different application of it that you haven't seen before. This is a 500 milliliter flat bottom flask that I have boiled water in. And the stopper has gotten pushed all the way down in there. I got to get it out by the way of the other video on here. But how I did this is I set this on a ring stand, etc. Put flame into it, had distilled water in here, boiled water, and the steam would have purged almost all the air out of this. And then while the steam is coming out, put a stopper in there and shut it off. I got heavy fire gloves on. Grab that, push the stopper in, invert it, let it cool. So essentially I've removed almost all the air. So I have water vapor in here, a very low pressure, and that's it. I don't have a water vapor pressure table in here, but you've all seen a water vapor pressure table, or you can look one up. And at room temperature, this pressure in here might be, I don't know, 10 or 20 millimeters mercury. So air pressure is really trying to shove that stopper down in here. Now the thing is if you take a Bunsen burner, even with no glove on, and you put this over that burner, immediately the pressure is very low in there. A small amount of liquid water will pick up that heat of vaporization, boil. That small amount of water will expand greatly and make a huge bubble that'll fill this. This will boil right away. So you can boil this like this in your hand. Alternatively, when this is cooling down, I've done this with students in the room, put this under running water, under running water. You can see it condensing in there, taking away heat of vaporization, And after a little while, you take the glove off and you're holding it under the water with your bare hand and it's still boiling. And then you're taking water, ice or salty water that's been in the freezer for a long time, that's well below zero, and pouring it back over, it is still boiling. And you'd have to put your glove on because it's so cold, and it's still boiling. Because the pressure is, there's hardly any air, and the pressure's so low that it can boil at a very low temperature. You could keep doing that, I've never had enough time to do it. You could keep doing that until it starts boiling and you're getting slush in there, ice, and you're boiling slush. And that's what I call my triple point apparatus. I have, however, put this in the freezer and got it to where you have ice and water and vapor here, and you're at the triple point. And that's hard to get to. Now, odds are, some things to look out for when you do that. It will freeze all at once very quickly. That heat of fusion characteristics are completely changed when that pressure is very low. And that whole thing could go to ice in a matter of minutes. So you gotta keep open it every 10 minutes and turn it, let some ice form on the side, turn it, let some ice form on the side so it doesn't build up that pressure. And when you freeze water in a line in the wintertime, it's not that spot where it freezes, it breaks the line. It's that it freezes in that spot and clogs the line, and it keeps freezing and keeps freezing and keeps freezing, and it's pushing that water down the line, and it bursts the water down the line. And that's kind of what you got to keep in mind here. If you, as it freezes on the sides, if you can keep distributing on the side by keep turning it, you can keep it from growing in any one direction and breaking the glass. Your odds of breaking glass and destroying this thing are pretty high. It happens a lot. Can break it at the neck. And getting it out of here is, watch the other video, the kids like that one.